One of the things that's really important about Soils for Globe is that we are one of the few programs that actually has soil protocols and that is creating a database of soils around the world. So we study soil because it is a great integrator. It does a lot of different functions for us, and it really creates an anchor point for a lot of pieces around agriculture and so on. So as you can see here, it is a medium of crop production. It also absorbs a lot of gases. There's a lot of gas or gaseous exchange that happens between the soil and the air. So it is a producer as well as an absorber of gases. We use it, of course, for agriculture and for plants to grow for crops to feed ourselves. It also is home to a lot of different organisms. So when you look in the soil, you will, of course, see lots of animals and different types of organisms. Some are big, and some are very, very small that you can't even see with your eyes. On this side, it also is a recorder of human history. So it does create a record and keep a record of what has happened in that local environment. And some of this you will see through the types of soil that are actually created in an area. And we will talk about that in a minute. It also decomposes a lot of waste. Can you imagine if we didn't have some of the soil decomposers, how much waste we would have around the world? It would be over our heads if we didn't have these organisms that decompose the waste that actually appears on soil. We also, of course, as humans, we use it as a construction material. We have used it in arts. We have used it in medicine. There are different, a lot of different uses that we as a species put soils to. And then it's also a filter of water. When water falls on the soil, it is filtered down through the soil and goes to different places, which I think the next slide shows. So water and soil interact very well together. Some soils hold water really, really well. Some soils don't. So when water and soil mix together, sometimes that soil is held, and we call it soil moisture, and we have a measurement for that. A lot of that water is also lost through evaporation from the soil. So in very hot conditions, that soil is also, or sorry, that water is also lost. Through evaporation, transpiration, and also through leaching. So once the water comes down here, it can flow through the soil. It goes down in here. It can become part of this groundwater area, this area here. And it eventually goes back into other areas of water, and then it goes back up into clouds. So this cycle, called the hydrologic cycle, uses soil as part of that process. So here you can see a more in-depth diagram of what happens with the water and the soil. So here we have little pockets of water that become very, very important to plants to be able to grow. It's a very important measurement that we take as part of the GLOBE program. We also look at the color of the soil. We look at the structure, because the structure really determines how much water can also be held by that soil, as well as texture. Texture is also a very important aspect of soil. We look at how deep the different layers or horizons of soil are, because they also impact the type of soil that you have. pH, of course, is very important because some plants will not grow if the pH level is too high or too low. And then we also look at temperature. Temperature, of course, is important because it helps plants to germinate. It helps and allows animals, certain animals, to live in the soil at certain temperatures. So, when we look at soil composition, we look at a number of different areas. One of these is organic material, and organic material, of course, is plants, animals, other dead material that's in the soil. And this is very important because it holds a lot of nutrients for other plants to grow. Minerals are also very important because they are required by certain plants to be able to grow. And we, of course, also extract minerals from soil. The amount of water and the amount of air in the soil are also very, very important. If we had one ideal soil all around the world, this is what we would look for. We would look for something that has 25% air, that has 25% water, some organic material, not a huge amount, but some organic material, and then the rest of it is minerals. So this would be our perfect soil. We do not have perfect soils around the world. We have to do with the types of soils that we find in areas. And so the types of soils that we find in areas are governed by these different factors. So these soil forming factors are very, very important in the type of soil that is actually formed in an area. So the parent material, so is there limestone or sandstone or some other type of geologic feature underneath the soil that helps to create it? What's the climate in the area? So here in Vietnam, because it's so hot and humid, you would have a very different soil than in Colorado, where I work, because it's very dry. It's hot, but it's very, very dry. So we would have a very different type of soil than you have here. Also, a very different soil than you would find in Siberia or Alaska, where it gets very, very cold in the winter. So heat, rain, ice, snow, all of these environmental factors are very important in the formation of soils. The type of plants and animals that you have, some of these microorganisms, for instance, may be very good at burrowing down into the soil and creating lots of air spaces. So that's going to change the composition of the soil. If you don't have a lot of those animals, you may not have a lot of air spaces in the soil. So the types of animals, microorganisms, and the plants are going to create a very different type of soil. Then the topography of the soil, so where the soil is located, if it's up high or down low, if it's in a basin or in a valley or on a mountaintop, very, very different type of soil in those areas. And then finally, time. Time is very, very important in soil formation. It takes a long, 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 long time for soils to form. So time is a very, very important factor in all of this. So these 5 factors, how they interact with each other, determines what you're going to find here. And you can see here that there's different areas. So these are all of the different types of horizons or layers that you're finding in the soil. And they're different based on these factors and the types of plants that you now see growing on the soil. So the different types of soil, again, are also dictated, as we said, by the plants that live in that area. So this grassland, the color, for instance, and the types of horizons are very different than this particular one, which is a forest, and this particular one, which is a very dry region. So each of these soils are very different. They will allow us to do different things with those soils and different crops to be able to be grown and so on. So this is very, very important, and this is why Globe actually is very interested in looking at these different types of soils and the horizons that are available. Okay. So in Globe, we look at two main areas of soil. We look at soil characterization, and we look at soil moisture and temperature. So these are the two big areas that we look at, and we'll be doing some of this later on. So the areas within soil that we look at are structure, color, and you can see here that the colors are very different. The consistence, the texture, and whether there's carbonates available or not in the soil. And then soil moisture and temperature, we also look at those and we determine those at different depths. So in Globe, we look at soil characterization and we look at soil moisture and temperature. Okay? Right. We do a number of these different protocols in different areas. So some we can carry out in the field. Some we can carry out in the field. Some we need to do back in the lab because they require additional equipment. And again, for the soil moisture, we do some of these in the field and some in the lab. Okay? So, when you're preparing to go out into the field, there's a number of different steps that you need to take before you get there. One, you fill a bottle with acid for the carbonates test. And so when you pour acid onto the soil or onto rock in the soil, you're looking for the presence of limestone, right? Because that acid will react with the limestone. You also bring some water with you because you're going to be taking some soil and rubbing it in your fingers and in your hands to look at the texture of the soil. For the soil moisture, you want to collect samples. So you're going to do this in containers, and you're going to bring those containers out with you. But before you do that, you should find the can mass, or the mass that the can that you're taking with you, the container that you're taking with you, will hold. You check the volume, you label the can, and then you hammer a hole in the can as well. And the reason for that is that as you're taking the sample, you want the air to be released through the base of the can. So you hammer a hole in the can. Okay. Now there's a number of different ways that you can do the soil characterization. One is you can create a big soil pit. Okay? So this is something that takes a lot of work to do because you're creating a big pit into the ground. You're going to dig down about 1 meter, which is quite deep, and you're going to then use this soil pit to look at the different horizons that are in the soil. Okay? A lot of work to dig that hole. You can also use a soil auger, which is this instrument here, and go down a meter if you don't want to or you can't dig the soil pit. Lots of schools around the world that are involved in this particular protocol do not dig the soil pit because they can't get permission to do it on the school site. So they use the soil auger, which is perfectly fine, to do that, to get your soil sample. You just need to go down a meter in depth. If you can't do either one of these, or if you want to use another site in addition to your school site, you can also look for exposed roadways and look at the profile there. So this is along a roadway. Here's the roadway, and if there's an exposed site, you can also use that. Or you could use it and compare it to your school site here, if you wanted to do that as well. The other thing, if you have very limited ability to be able to dig or to do an auger, but you really want to look at soils, you can do this very simple method, which is just going using a garden trowel, and you're going to the top 10 centimeters of soil. So you would just use a very, very small soil sample, if that's all you can do. So you might not be able to do the soil characterization or a lot of the soil characterization because we really want you to go down about a meter for that particular protocol. Okay? So when you're starting to look at a soil profile, you start from the top and you're observing down the soil. So you start here, and then you work your way down. Everywhere you see a change in color is where you would put a marker. And you can use different types of markers. It can be a golf tee or a nail or something like that to actually show where the different colors start and end. And each one of those is a layer or a horizon. And then when you are looking at these, you're going to look for different colors, shapes, roots, the size and amount of stones, small dark nodules, which are also called concretions, any other animals that are in here. So you try to describe each horizon as much as you can. Okay? And then within each horizon, you will do a number of different tests. And so the tests that you will do, you will start looking at soil structure, soil consistence, soil texture, color, and the presence of carbonates or not. And this is the one that we use the acid for to test whether there's carbonates available or not. So soil structure is the first area that you look at here. And the first type of structure that you might find is what we call granular. And it looks like cookies or biscuit crumble. They're typically 0.5 centimeters in diameter, so pretty large. And they're commonly found in the surface horizons. So up at the top of the soil profile that you're taking is where you tend to find granular structure soil. So you can see it looks like cookie crumbs, and this is an image of it here. Okay. Another type of structure that you might find is blocky, and these are actually pretty big in size. They're 1.5 to 5 centimeters in diameter, and they're pretty big pieces or beds of soil. Then you can also find this one called columnar, and it's silt feels very flowery. It feels very smooth, and the smoothest one of all is clay, and this of course is very sticky when you wet it. Okay. So how we do soil texture is we're going to feel it. So soil texture depends on the amount of the size of each piece or particle of soil. So when you feel it, you'll be able to feel the difference. So sand, silt, and clay are the names that are given. So sand, they feel gritty. Silt feels flowery. And then clay is the smallest, and they tend to feel sticky. So when you wet the soil and you do this, you'll feel the difference. And it's one of the better experiences for people to actually feel that difference in soil. And then you have the soil triangle, I believe, here. But depending on the amount of different components within the soil, you label them differently here. So you test for clay first. If it's very sticky and hard to squeeze, you can form a long ribbon or a worm without breaking, and it stains your hand. It's called a clay soil. If it is like a clay, but much softer and not as sticky, you call it a clay loam. So this again depends on how much of the other materials are in the soil. And if it's very, very soft and not like a clay at all, you call it a loam. So these are the major areas that you would call the different soils. And they're all based on the texture of the soil. And then you can refine the amount of, you can refine the type of soil by looking at the different types. And the next thing that you do is you feel for sand. And if the soil is gritty, then you add the word sandy to it. So it becomes a sandy clay, If it feels flowery, as the clay, you call it a silky clay. So again, you can refine how you explain the texture of the soil, depending on how you feel it. And then you would record the texture name class in the data sheets as you enter the data. So you can break it down from clay to sandy clay, silky clay. You can also determine if there's some loam in there. And then if it's just loam and silt, or sand and loam as well. Okay, and you have those triangles, I believe, in front of you as well. Okay. Color. So we have a color guide here that you can use when you're looking at the soil. And of course, you do want to wet the soil a little bit, so you take a piece or a ped of soil. You take a ped or a piece of soil from each horizon. So you want to find the color for each different layer or horizon that you have identified. And you will wet it with the water bottle that you brought. So the water that you brought in the bottle, you will wet some of that. And you stand with the sun over your shoulders so that the sunlight shines on the color chart and the soil sample. So you don't want to do it in the shade. You want to make sure that the sunlight is shining on both the book and the soil sample. And you will compare the tiny piece of soil then to the color chart. And underneath each of the color charts or color strips is a code, and that is the code that you will use to enter the data. Okay? So, and sometimes a soil sample may have more than one color. You could record a maximum of 2 colors if you want to, but it's unlikely that it's going to have more than 2 colors. Okay? Generally, soils just have 1, but sometimes it's difficult to distinguish between a color as well. The other thing that we would suggest is that you have a number of different students look at the color, because sometimes our eyes see color differently, so it's good to have more than one student check the color as well. So once you do this, you would actually enter the data, and this is the area of soils. As I said, GLOBE is the only program that's doing something like this on a global scale. So your students would be creating a global database for soils around the world, which is very helpful to soil scientists. So carbonates is the next test that you would do, and this is with the acid in the bottle. So you are looking for free carbonates or compounds that coat soil particles. They form under certain conditions, and the pH is above 7. And carbonates, an example of carbonates are limestone. So what you would do is you would, like this, if you have a soil pit or a horizons, you would put the acid, onto the different horizons, and then you would test to see what the reaction is. So if there's no reaction, then there's no carbonates on the soil. If you see a slight bubbling, then there is some carbonates. And if you're in an area where limestone is the base of the soil, which you can be in some areas, you will see a lot of bubbling going on. And that means that there's a lot or a high percentage of limestone or some sort of a carbonate on the soil. Okay, so for bulk density, we're going to go past those slides because bulk density is something that you do in the lab and it requires a lot of equipment. So we're going to go on to pH. Okay, so soil pH is very, very important because, of course, it governs the different types of plants that we can grow from an agricultural perspective on the soil. So here you can see that pH 7 is neutral, and as we go down the scale here, we become more acidic, and as we go up the scale here to 14, we are very basic, right? And it's very unlikely that any plants will grow beyond this point here or this point here, because it's either too acidic or it's too basic for the plants to grow. In agriculture, the most desirable area is for here. Okay? So when farmers sometimes add different chemicals or different organic matter or limestone or something like that to the soil, they're trying to get it to a point here where they can grow their crops. Here are the different ranges that certain crops actually can grow at. So apples tend to grow best at this pH range, spinach at this range, tomatoes, this, cranberries here, wheat, cucumber, carrots, white pine, and black walnut. These are all the different ranges that certain plants can grow at. So as a farmer, if you're trying to determine what kind of crop you can grow, a lot of it is based on the pH. Not all of it, because rain levels and temperature are also important, but in the soil aspect, This is really an important characteristic. So we're going to do soil pH. So we're going to take the pH of distilled water. Then we're going to mix the soil and the water for 30 seconds every 3 minutes for a total of 5 stirring or waiting cycles. So here we're going to allow the mixture to settle and wait for a little column of water, or supernatant it's called, to develop, and then take the pH by putting the probe into that. And then we will record where we are here and what pH. Why we study the soil temperature, weather. So soil temperature influences the weather. The temperature of the soil can also affect whether we have fog or whether snow accumulates, which is not a problem in Vietnam, right? No snow? Some? Really? Up north? Up north? On the mountains? Okay. But not here? No, no. Not here. Soil moisture is also very important because, again, how warm it is will determine how quickly the water evaporates from the soil. The land cover, so the types of plants that are going to be growing in the soil and how quickly seeds germinate in the soil is determined by temperature. And soil is also an insulator, and it maintains temperature in different areas. One of the things that we're also looking at, and that we'll be doing training later on in the week, is around mosquito larvae. Mosquitoes, of course, are also governed by soil moisture and the temperature of the soil, because they can also be born in soils. So the temperature of the soil would also be important for animals like that to hatch. Soil temperature affects animals, okay, from the smallest ones all the way up to some larger animals that live in the soil, and then plants. So soil temperature is a part of the energy cycle on the earth. It helps to moderate some of the temperature, and there are important seasonal and diurnal changes that happen because of the sun coming in and hitting the soil. But then also the temperature of the soil changes with soil depth and also soil type. Okay, so a good experiment perhaps for you to look at with your students would be the difference in temperature between the air and the soil. And why does that happen? Why, if there is a temperature difference, why does it happen? Right? So there's lots of reasons why that happens, and you could help investigate that with your students. So where to do soil temperature? It should be within 10 meters of your atmosphere study site. You do 3 measurements at 5 centimeters and 3 measurements at 10 centimeters. And again, this is looking at the difference in the soil depth and what type of difference that might cause. It could also be that there's different soil horizons, right, at 5 centimeters and 10 centimeters. There might be. There may not be, but there could be. So looking at the difference in soil temperature at these 2 particular depths is important. The 5 centimeters is also important for soil moisture, and looking at the soil moisture at this particular depth. And then the frequency for taking these measurements is weekly and seasonally. So depending on the number of seasons that you have, some places may have 4 seasons a year: winter, spring, summer, and autumn. Some may have just 2 seasons, a wet and a dry season. And so looking at those seasonal differences can be important, as well as looking at weekly temperature changes. How you actually do the soil moisture, you can measure at 5 centimeters. The tip of the thermometer is usually 2 centimeters from the tip. So you actually go down 7 centimeters, right? When you have a soil thermometer like this, the actual measuring point is not at the very tip. So you have to go down 7 centimeters to actually take that measurement. If you're taking it at 10 centimeters, it's exactly the same thing. You go down 12 centimeters and the thermometer will take it at 10. Okay? All right? Yes? Okay. And this is how you would take it. You can see there's a little column here, or PVC pipe that helps to protect the thermometer, because you don't want to push the thermometer directly into the soil, because the soil sometimes may be so hard that you might break it, you might damage the thermometer. So you want to use a PVC sleeve to go down into the soil. And if you're doing it at 5 centimeters, how long would this sleeve be? 7, right? And if you're doing it at 10 centimeters, it would be 12. Great. Okay. Okay. There was a lot of information pushed at you. Have you any questions? We will be we'll be doing these, so you can also ask questions at that point. So, can we get some water and vinegar, please? So, if you look at these soils, what do you notice right away? What do you notice about what do you notice about this versus this one? So it looks very different, right? It's a different color, right? But it's also, these little guys are very different than this little guy, right? So there's some that are big too, but they don't hold together well, right? When I try to pick it up, so what do you think this is? Already? What do you think if you feel this? It's gritty, so what would it be? Sandy, right? So feel that? Can you feel it? Yes? And this one, okay? Okay, thank you. This also is, it's not as easy. You need to squeeze it to break it apart, right? You need to put some pressure on it. This one falls apart very easily, right? And so here, if you're looking at consistence, right? It's loose. This one is very loose. This one you have to apply a little bit more pressure, so it's either friable or firm. Which one do you think that would be? You think it's this one or this one? This one? Firm? Yeah, you have to apply quite a bit of pressure to it to actually get it to break apart. Right? It's not this. You can actually break it with your fingers. So it's probably firm. It's probably actually more between friable and firm, but you still need pressure to actually break it apart. Okay? All right. Everybody see the difference between those two? Yes? All right. You would also look at the color, right? If you were doing some of this. Is the color the same? Different? So this is black, right? It's darker than this. This one is more browny. So we don't have any books here, but you would look at the book. You would open up the color pages on the book, and you would describe the colors that particular way. Okay? So let's look at, is this? Okay. So for the water, to look at texture here, right? You would Oh, there we go. Great. So, can you find the color of this in here? So, what are we looking at here? Is it a brown? Does it look browny, or does it look... So, can you... Let's put that over there. So, which one do you think this color is here? Now, if you're doing this outside, right, you want to make sure that the sun is shining, that there's no shade. No shade on this, and no shade on this as you're looking at it, right? So, it's probably good here in the light because there's no shade or shadows on this. So, you can take a little piece, and you can do this. So, no?
No. Yes. Yes.
Yes? You think it's there?
No.
Let's look over here. No, right? No. Here?
Yes.
Or here?
Yeah.
This one? So you would record on your data sheet here. Land cover. We don't have this here, I guess, because it's temperature, but you would record this number. Okay, 10 Y or 3/6. Each of these is different, see? This is 10 YR, but it's 4/6. This is 10 YR, but it's 5/6. So you need to record the whole number in the data, and then this is, you get these color books anywhere in the world. So soil scientists are using the same colors to describe soils around the world. So then they know when you put this into your database, they know that it's representing this color. Okay? Alright, let's try this one. Let's get a ped here. Alright. Who would like to try and find this one?
No, I think yeah.
You think it's the same, or you think it's different? You can put it on here. This is there. Let's look at this. Is it here?
Yes. Yeah, dark brown.
Yes? So this one is 10 YR33. Okay? So again, you should look through all the book before you make your decision, because sometimes you open the page and it might look like this color that we saw, but it might actually be a different color. And you can see some soils, look at that, red, green. Have you ever seen a green soil?
No.
Yes? No? No? You often see in forests or in swampy areas, if you dig down in a swampy area, you can often see a green soil because it's so waterlogged. There's a chemical reaction that happens in the soil that turns it green. So, okay, so this book.
Sorry?
Yes.
Maybe you put that here, but I think some people different eyes.
Different eyes? Yes. That's why you should have a number of students look at it, because sometimes people see different colors with their eyes. Some people wear glasses. Some people have different eye strength, so it's good to get a number of students to help decide if that's the color or not, right? And so if most of them tend to agree that this is the right color, then that's the color that you can choose. There's not a lot of difference between these types of soils. So it's okay to have some, like if people are saying, no, I think it's this one or it's this one, just choose one that the most of the students would actually agree on. Okay. Alright, so let's, so if we, oh, vinegar, thank you. Okay, it's better if you have a spray bottle for this rather than that, but so you would take a small little bit of soil and you put it in your fingers and you do this. Okay? So, if you can form a ribbon, right? This is forming into a ribbon, right? So, what does it say here? If you can, hard to squeeze, stains your hand. Yes?
Yes.
Yes? Has a shine when rubbed, and forms a long ribbon without breaking. So what do you think this soil is?
It's clay.
It's a clay soil, right? Let's look at this one, right? And if we wet it,
Water.
what happens? It falls apart, right? You can't even rub it together.
Yes.
So then this one is sand, right? And if you rub this, you can feel that it's gritty. It's very gritty. Okay. So anybody want to try this? You could probably get a little bit more of this. And now do this. And try and rub it in there, see?
Như thầy nói đó, khi đấy mình phải để cho ánh sáng.
So it's forming a ribbon, right? And it's going to be clay, right? Because it's far more, and you can feel the grittiness on this. If you rub you can feel the little sand particles here on this. But then you can't really feel particles that much. Okay? So this is how you would do the soil texture, right? Between the sand here and the clay soil, right? And you can even see the difference, right? Between, there's a lot more of these little chunks, right? Than there are here. And when you pick up this chunk, sometimes they fall apart very easily because they're a lot looser. Okay? But you can see that there's not as many of those, right, of these chunks. Because this is a clay soil and this is a sandy soil. Okay? Alright. The other one, the other one that we want to test is, the other one we want to test, this is vinegar, and vinegar we want to use to test, carbonates, right? pH, we'll do that with a pH meter and a vinegar. So with the vinegar, what you want to do is, you would, again, it would be better in a squirt bottle, if you had a little squirt bottle. And I'm going to take another chunk of this here. Well, let me get a dry one. Okay. So you would get a little, if you have your soil here, you would just get a little bit of vinegar. Is there any bubbling going on? Do you see any bubbles? No? No bubbles, right? So if there's bubbles, it means that there is carbonate. But no bubbles, no carbonate. Okay, so no bubbles, no carbonate. So this does not have any limestone or carbonate kind of substance on the soil. Okay? So this is just vinegar.
Yes.
Or a weak acid. You would use a weak acid as well.
Đúng rồi, nó có bong bóng lên thì là có khí carbonate còn được.
No, we want to do pH. And
pH.
This is too much water. We have
The
another
thermometer.
container.
Thermometer. Phải là cái kia.
We need the pH meter for this, but we need to mix some soil and some water together. So this is the pH meter.
Chị ơi, bên đấy có cái máy đo độ pH không? Em mượn.
Yeah, is there another
pH thermometer.
of soil and water? So I'm just going to guess this. We'll use this one. Okay. So actually I need a little bit more than that.
Thế sao chị nó sao chị? Em mới nhớ sao có cái gì không? Thức kể. Lấy cái bút được mà. Lấy cái đuôi cái bút đi. Chị ngửa cái bút này đây là ngoái được à?
Yes.
You can stir.
Oh, thank you. So you stir this. Yep, you can use that too.
Just like chocolate mix. You will make
That's this one, yes.
how much?
It's the same amount of soil and water.
Mà mẫu ra hết rồi. Đây này. Ô, không. Hãy đổ cho 3 mẫu vào xem. Mấy chục giây. Tí nữa. Bằng nhau lượng đất đến nước. Tương đối. Ông ý đổ.
You would use a graduated cylinder to use for the water and measuring scales to measure the amount of soil. So if it's 100 grams of soil, it's 100 milliliters of water. But we don't have those, so we're just trying to guess. Is it all?
Máy 30 giây xong rồi dừng 3 phút thì máy giờ bây giờ nhỉ. Tóm lại ngoài đang lạnh rồi đâu. 30 giây còn là 5 lần đi. 30 giây rồi 3 phút. Máy trong vòng 3 phút rồi đợi trong vòng 30 giây đúng không ạ? Máy 30 giây ai đã thế ạ? Em không nhớ đợi 3 phút, máy 30 giây. Làm 5 lần. Không sao đâu. Mình ngoáy là để hòa tan nhiều nhất có thể các thứ ở trong đất, sau đấy mình phải để lắng 3 phút bởi vì mình sẽ không cho cái đầu máy đo pH vào xuống đất mà mình chỉ đo cái dịch ở phía bên trên. Thế tại sao mình lại phải làm 5 lần nhỉ? 5 lần đợi chính xác nhỉ? À, 5 là số.
So this one is not working. It's all still working. Okay, so what you would do is once you have this mixed up, and your soil would actually be dry before you put it in. So you would take this, so once you take your soil sample, you would take it back to your classroom and you would dry the soil. You can just leave it air dry, and then you would put it into the water, and then you will stir up the water, and then you just want to get you just want to measure the liquid. You don't want to push this down into the soil, just the liquid. So let's just push it down there, and it is, oh, sorry. So what is it? 7.5? Okay, so this one is the clay soil, right? Yes. So let's actually, now we need to wash this off. This one. 7.6. Oops. 7.6, okay. This one.
Cái này là cát đúng không ạ?
This is a sand, right? Sand, right?
And there's a lot.
This was the one in the middle, I think, or it might also be a clay soil. Yeah. So we've got, I think, 2 clay soils and a sandy soil, and there's difference in pH, right? Not a huge amount of difference, but there is a difference, right? So you record that difference on your in your data sheet. And then you might try to figure out with your students why is there a difference in the pH, right? And it depends on where these soils were taken. I don't know where they were taken. So they could have different plants growing on them. They could be in different locations. So there's differences associated with each of the soils, okay? And that impacts the pH. Okay? And remember that pH, the difference between the 7 and an 8 in pH is very, very big, right? It's not like doing 1, 2, 3, 4, 5, 6, 7. There's a huge difference in magnitude between a 7 and an 8 in the pH scale because it only goes up to 14, from 0 to 14. So that if you see a difference of 7.6 and 8.1, that's a big difference. And it can make a big difference to the types of plants that grow in that soil. Okay? Alright.
Can we finish this section in 5 minutes?
Sure.
Thank you.
The only other one that we were to do is soil, is temperature.
We will connect with the other protocol.
With the other, okay,
yeah.
great. Then we're done.
Yeah.
We're done.
Okay.
Okay. Any questions?
Cái đây đo cái khác ạ? Đo cái nước, đo cái khác.
Thank you.